Hello everybody, welcome to this presentation. The session will focus on PowerServer 2019 and PowerBuilder C# Web API integration. Why, when, and how. You will learn how to utilize the new features of PowerServer 2019 in conjunction with PowerBuilder 2019 to free your app from the desktop and from the limitations of a client-server architecture. As usual, let me just remind you that this is a volunteer-based community presentation and the user opinions may not necessarily reflect those of Appeon. It's a really exciting time to be involved in PowerBuilder development at the moment. In fact, the new PowerBuilder 2019 C# Web API opens up new possibilities. And this is especially true for PowerServer enthusiasts like me. Thereby, in this community webinar, I will be telling you how to integrate PowerServer and the new C# Web API. So the agenda for today, I will recap what PowerBuilder edition you need to use, and in particular, what is the deployment architecture that you target with PowerServer and the Web API. Then I will turn to the gist of this webcast, the reasons for an integration between PowerServer and the Web API. I will share all the architectural knowledge of the two solutions, why you need the first rather than the second one. I will discuss when you may want to favor PowerServer instead of the Web API, with pros and cons. Then the how-to comes, discussing the implementation efforts and PowerBuilder objects available for the integration. I will then go through a number of integration examples based on personal experience so far, and discussing PowerScript versus C# code and targeting also performance. And finally, I'll put everything into one demo and run it. Talk about me for a little bit. PowerServer is my daily development framework. I have spent the majority of last 10 years in about hundreds of migration projects from 2 tiers PowerBuilder applications to 3 tiers web or mobile platform. I try to be an active Appion MVP in the Appion Community Q&A and the webcast. I am also speaker at Elevate conferences in US and PowerBuilder user groups in Europe. But besides PowerBuilder, I've kept myself busy over the last 5 years with a PhD in machine learning techniques applied to big data infrastructures. Very cool stuff if you need to shred or mesh up some petabyte or even exabyte of raw data. As you already probably know, PowerBuilder is delivered in 3 editions. You may want to skip the standard edition if the goal is developing N-tier solutions. The Cloud Edition offers all you need to develop ASP.NET Core Web API from the PowerBuilder IDE or from a brand new C# IDE called Snap Develop. You can leverage .NET Data Access objects like .NET Data Store and .NET Model Store so that your technology shift from PowerBuilder data window to C# REST services is simplified by automatic transformation tools. In addition to Snap Objects library, provides very simple, very powerful, and very fast object relational mapping integration for .NET. The Universal Edition instead is what you need to enable the PowerServer toolkit in PowerBuilder and readily deploy your PowerBuilder desktop application to a middle tier as a web app or a native mobile app for iOS or for Android. Either PowerServer and C# Web API enable your enterprise applications on top of an N-tier architecture. They both let you build applications that are different from traditional legacy fat clients by introducing a middle tier where entirely or partially your business logic is executed. This picture sketches the main tiers of the architecture. Each tier or layer has a precise purpose and does not have to be necessarily in the same physical machines. You can have web server, application server, and database in different machines. And you can even spread across multiple physical machines in a single tier. Enterprise application can thereafter scale up the business logic to clusters of PowerServer machines or REST API instances and offer load balancing and failover functionality. So to recap, both applications deployed to PowerServer or embodying the new C# Web API are logically split across the client layer, the middle tier, and the data tier. But there are differences that I'm going to highlight in the slides to come. Let me start from the background and say why today the focus is on PowerServer and Web API integration. First, a short reminder of how PowerServer works, or a quick explanation if you never tried it yet. So from the native PowerBuilder source, PowerServer generates end-tier applications that can run on the web or on mobile environment. In the first case, you obtain, identical fat client user interface, which is made, however, of HTML and JavaScript, plus a plugin that takes care of communications, data handling, and security. If on the other side the target infrastructure is mobile, you can also access iOS and Android native features, but still programming in PowerScript because a set of additional PowerBuilder objects is provided by the IDE for things like automatic UI resides, GPS, maps, camera, NFC, and so on and so forth, in a matter of few lines of PowerBuilder code. The application business logic, including data window and transactions, data connectivity, and PDF handling is deployed to Java or .NET backend. So there is no need to give up on your PowerBuilder native functionality. From the partitioning point of view, the PowerBuilder application is exported to source code, and objects in the PBL are split in order to build the presentation tier with graphical objects that are converted to web files that will reproduce the UI of the application. And as far as the business logic is concerned, data holder and data container like data window will be replaced by J2E or .NET objects running on the server side, which are part of the PowerServer implementation. Let me clarify that PowerBuilder MVO, being PowerScript, are converted into JavaScript classes too. So they are here in this part of the split. So if MVOs include embedded SQL, those are wrapped into server calls and transmit to the server objects. What you get in the end is an end-tier web-rich application that lets you have complex functionality and advanced graphical interface with multiple windows, one on top of the other, like in a typical fat client MDI application. Instead, a web API, also known as a RESTful API, is an API that uses HTTP requests to get, put, post, and delete data. So a web API is based on representational state transfer architecture, which is used in web services development. When the REST client accesses a REST service, it indeed accesses the resource, the actual data. Your REST client can be any regular PowerBuilder desktop application, or web or mobile apps via PowerServer, or any other application developed in whatsoever language you want. On the server, it is the controller that handles the request and passes it on to the service, which in turn processes the request and prepares the response, typically in JSON format. It is the content type of the response that informs the client what kind of representation, and this is where the letter T of REST comes from, what is the kind of representation of the data. And the database is, of course, the usual backend where data is stored, and it is accessed through data context and object relational mapping layer. In the future releases of PowerBuilder, Web API will embody a fundamental role. Most likely in PowerBuilder 2021, you will be able to build desktop cloud applications powered by UWP, Universal Windows Platform, which is now open source in the .NET Core framework and REST API. So the app on the client will install and update over the internet, and updates would be automatic and incremental. And the communication between the app and the server will be over REST Web API and HTTP. Basically, it is similar to modern desktop applications that are powered by cloud backend. Now, when would you go for PowerServer or Web API, or rather both of them? So let me answer by a recap of pros and cons of both approaches before discussing the need for integration. Pros of PowerServer are easy to figure out if you are legacy PB developers and need to provide a fast upgrade strategy to web or mobile platform. It's easy to interface Java or .NET Server objects if you use PowerServer. It's a robust three-tier platform with hundreds of success stories over the last 15 years. You don't need to learn any new language, C#, JavaScript, .NET, HTML, just PowerBuilder. And it delivers entirely the existing UI and business logic to web and mobile platform through a super fast migration without any loss of functionality or performance. And you write once and deploy anywhere, so you just keep one version of your source code and you can compile it as a desktop application, as a web app, or as a mobile native app. And it's easy to develop apps for iOS, Android, and using native functionality of the two operating systems. However, what are the cons? PowerServer is a deployment, by the way, solution that shifts PowerBuilder applications to entire architectures. With little effort, PowerScript goes web and mobile. However, the target applications leverage JavaScript. JavaScript can bring performance issues with heavy scripts or with too many round trips to database across the internet for a given operation in the PowerBuilder application. This is fine on a local area network because these networks is so low latency, but on the internet, this is a big performance issue. So this said, you will argue that PowerServer doesn't really separate out business logic from the client application. With PowerBuilder MVOs, that is usually your business logic and embedded SQL that are still executed on the client side, and when the business logic gets very complex, there is a long list of historical hacks or workarounds for moving the business logic to middle tier or even to the database, like get set full state of the data windows, storage procedures, SOAP web services, .NET assemblies implementations. Now, there is an alternative to use the C# web APIs instead of storage procedure or PowerScript refactoring to move those database server calls from client side to server side. The new PowerBuilder 2019 C# Web API feature offers the perfect scenario for supplementing large PowerServer-enabled applications with full-fledged .NET Core and C# REST API. So the C# Web API solves the problem of code that you don't want to be SQL-based, but rather service-based. So a great pros of Web API is performance speed up. I will provide you later an actual comparison between pure PowerServer and PowerServer plus API. Another benefits of C# Web APIs is, well, you don't have unsupported feature. Currently, there are some PB features that are not supported in PowerServer because the underlying JavaScript. So by using C# Web APIs, the developer doesn't need to work around or remove certain features. And related to this point, some customers complain about PowerBuilder itself and say, its features is too limited compared to C#. Well, now there is C# Web API, the PowerServer application can do even more features than original PowerBuilder app because C# has more extensive feature set than PowerBuilder. Aside from features, another key benefits of C# Web APIs is to expose the application business logic to the world for integration purposes. It might be exposing to another app developed by the same customer so they can share business logic between multiple applications. And it might be exposing to another app developed by, say, a third party so that the systems talk to each other and exchange information. And the last but not the least, with C#, you can C# Web API, C# Data Store, you can reuse most of the PowerBuilder data window handling functionality. What about Web API disadvantages? Of course, you need to learn C# and the .NET Core libraries. But this should be far from being a problem. Do not underestimate yourself and the fact that you are a developer, not just a PowerBuilder developer. The UI is not included in the package, in the sense that C# Web API in PowerBuilder is a non-visual feature. That's why PowerServer 2019 represents the easiest and the fastest solution for delivering the web or mobile UI to your project. Or if you want, just look out there. You will find lots of web UI frameworks, but it's not gonna be as fast and as effective as PowerServer, where you can stay with PowerScript and data window development. So to put everything in one recap picture, you should think of PowerServer and C# REST API integration, especially if you have already undergone PowerServer migration efforts, but want to transfer some heavy computation to the server. So the web API are implemented in C#, but PB 2019 and the new IDE Snap Develop 2019 provide lots of utilities specifically tailored to PB developers to simplify the plumbings. You can have PowerServer and Web API on the same server box or on different instances. Web API is based on cross-platform .NET Core. PowerServer can be deployed to both .NET Framework or Java servers. And then you can complement REST API and convert your application UI into a web or mobile app that consumes this API utilizing the new REST features of PowerServer 2019. How do you actually make up this integration? Let's go technical now. So PowerServer is actually little effort. PowerBuilder to PowerServer is very easy. In PowerBuilder Universal, you get an additional toolkit, this toolbar over here, which lets you configure how and where the deploy of the PowerBuilder app is done to PowerServer. In the picture, you see an example of PowerBuilder application, and once the deployment is completed, each individual objects here, data window, MVOs, windows, etc., have a corresponding objects as a web files. So each individual objects in the PBL becomes web file along with runtime features belonging to PowerServer itself, of course. And these web files are stored on the server web root. This is IIS, so 3W root, inet pub 3W root. And these files are downloaded by the web browser or by the mobile client when the application starts the very first time. So very minimal conversion effort and fast learning curve. And here you see data windows and NVO have the equivalent files. Little deployment efforts, you may find some unsupported feature, you may hit some performance issues, but usually there is always a workaround to fix it up. When you migrate instead from PowerScript business logic to Web API, you need to learn how to structure your API. The picture shows on the left the business logic of the PowerBuilder application, while on the right the equivalent implementation in C#. You have to convert data window, so from PowerBuilder data window to, for example, C# data store. You need to convert PowerBuilder NVOs to correspondent C# classes. You need to convert transaction objects into proper data context. In one word, you must follow ASP.NET MVC and Web API specifications, where users interact with the controller up here, which manipulates the models down here, which updates the views, which is what is seen by the user. So with clients performing HTTP requests to get, to put, to post and delete data. PowerServer and Web API coding is of course different. C# is case sensitive, string are in double quotes, backslash escaped, and you have class methods for data conversion rather than system functions. You will also need to learn syntax difference in loops and conditions, but most of the attention goes to data handling with data store, because return code may be of different type. For example, set item, boolean instead of a number, or so error handle is not the same, and the first row has index 0 instead of 1. Likewise, arrays and collection is in C#, so be careful when you insert row or get and set items. But this is the way you learn the language, so it just takes a learning curve. Once that your business logic is deployed as Web API, you can use the new REST features of PowerServer 2019 to consume the REST services and have the PowerServer application sending HTTP requests to get the data via the HTTP client object, or have a data window able to stream the content directly from a REST service returning JSON data. Of course, the JSON generator objects lets your PowerScript client to store information in JSON format or parse it out if it is a JSON source. And in the next release, you can also use the built-in JSON import and export data window methods, as you can already do in desktop PowerBuilder application at the moment. There's a lot of materials on Appeon Community and Appeon U to get started with PowerServer and C# Web API. So in my demo later and in the next example, I'm not going to start again from the very basic implementation and technical stuff. So time to move to, this is the links that you can follow if you want to get a quick start of PowerServer, and also very nice tutorial for Web API. So now it's time to move to code assets and see how to make PowerServer and Web API working together. I will go through a number of use cases that should make you thinking of moving some portion of your business logic to Web API. So first one is handling of unsupported features in PowerServer, functionality in PowerBuilder for clients that cannot be migrated to PowerServer, or they may involve borderline solutions. With Web API, you can use .NET Core and, for instance, have a simple workaround to PBDOM, which is PowerBuilder extensions provided as a compiled library, so you cannot migrate it to PowerServer. But you can easily re-implement the same functionality with C# Web API. Another example is implement services like sending batch emails. Very useful in many enterprise applications today that needs to send out emails and notifications. Or on top of everything else, have your complex BL that runs on a server and is available as a high-performance REST services because it includes many round trips to the database, it fills a lot of memory structures, it is CPU or memory bound, and it needs data caching. High-performance solution that run better on the server side than client machine. And last but not least, .NET Core is open source, cross-platform successor of .NET Framework, and REST API is open standard. So, first example, a web API that manipulates data using the C# data store. Okay, so this is a method in your class, in your web API. The method gets data store as an argument, and you export the data. What you want to achieve in the end is generate an XML out of this data store using probably the link package. So the .NET query language that generates data source independent queries. So C# data store has an extensive API for manipulating JSON data, but besides that, so far you can only export data as a sequence of comma separated strings. So this example calls export string here, then splits rows by new line characters. And by the way, C# has a very large set of effective functions and collections for in-memory data manipulation. It's not just array and structures like PowerBuilder. You later split by commas because you have a list of comma separate values strings. So first of all, you split by new line, then you split each columns by commas, and create the XML by using the XML link objects to build XML elements and attributes that match the definition of the data store columns. So customer name, department ID, and so on and so forth in my example. Ultimately, you save the root of the XML elements to disk. So here to the right in this picture, you see the content of a PowerBuilder data window, which becomes a C# data store in your web API project, and the XML output. Few lines of code and no need at all for PowerBuilder DOM. So another very useful example is when you can integrate your PowerServer application with REST service for sending emails, talking to an SMTP server and send batch mail messages. In your web API, you can leverage the MailKit open source .NET Mail client library, which is based on MIME-Kit for creating and parsing MIME messages. So the example here creates a MIME message, first of all, specifying usual sender, recipient, and the subject. Then it builds the message body and specify attachment if needed. Then it configures the SMTP client with security and server settings, and finally it sends the message out. So as simple as that, while in PowerBuilder or PowerServer, we need to struggle with third-party libraries or wrap .NET assembly into convisible wrappers. So think about this solution. Now, let me do something which will probably match more closely your existing complex data handling in PowerServer. I want to demonstrate the performance boost that you can achieve with Web API. So to this extent, I will refer to the Microsoft SQL Server AdventureWorks demo database, which, among the others, contains two tables for sales order headers and order details. So I will mock up a model of a business logic that for each order performs some type of operation that are usually known as performance killer in PowerServer applications, like several round trips to database, um, dependent server calls, or I will fill memory structures, or also string concatenation and replacement. Actually, here I will focus on the first one, multiple round trips to database, and code optimization is not the goal, but you can agree with me that it is a typical use case that normally you cannot transfer to store procedure. And these round trips cannot be optimized because they represent interrelated retrieves or updates by means, for example, of data window retrieve at time n being necessary beforehand data window retrieve at time n plus 1 can be performed. So we will then actually compare performance in PowerBuilder client-server version of the application versus pure PowerServer versus PowerServer plus Web API. The PowerBuilder application will be our baseline because it, of course, runs using the machine code, which is very efficient at code level, and database connection in client-server is permanent, which allows for faster performance in local area network. But the converted PowerServer application executes the JavaScript, which will be suffering of low latency or extra communications that is typical in end-tier architectures. So the PowerBuilder code is in its fundamental shape like this. A loop over the retrieved sale order headers, so the master data window. Per each order, a cursor is declared for subsequent selection of detailed order information. And as I said, this is an implementation whose purpose is not discussing whether you can optimize data retrieve by some SQL join, but rather it represents a typical scenario where per each master row you need to do some operations. Can be calculation of monthly payrolls for all employees of your company, can be statistics on all history cases in a hospital, or like in this case, total incomes for all items of all orders in a given period of time. So the fetch here, the fetch line gets the sale order detail data, and in the cursor loop here, the amount variable, this variable, gets updated at each iteration to signify some, some calculation that occurs per each line, per each step of the cursor loop. This is the equivalent code in C# Web API. You can use the Snap Objects library, which provides very simple and fast ORM integration for .NET. We start again from the sale headers retrieval, then we declare a collection of order detail data model where sales order detail data type is automatically generated by the PowerBuilder C# model generator from a data window object. The SQL builder here constructs SQL statements programmatically and in a database agnostic way. Here we actually use SQL query builder because we need an object to build a SQL select statement. With this SQL builder, you only need to build a syntax structure, and database-specific SQL statements will be generated based on the syntax structure and the data context. That is, in this case, you select a list of columns or relevant fields from the sales order details and where the order ID matches the given input value. So SQL Builder is a very handy feature in Web API. It removes the headache of mastering the SQL statements for various database types. Within the loop, then, what happens? The SQL executor executes the select prepared by the builder, and for each order detail into the order details collection, we can update our total amount by adding quantity times unit price minus discount per each item. Okay, so that's the equivalent implementation in C# for your PowerScript cursor-based business logic. All in all, we come up with this benchmark. The plot shows number of seconds to compute the total cost versus number of orders retrieved from the database. And we execute the code from the previous slide in PowerBuilder client server, in PowerServer, and finally in PowerServer web with order handling moved to C# Web API. So, and also we execute the code in 10 rounds, each time increasing the number of total orders by 1,000. So we start from 4,000 orders, 5,000, 6,000, up to 13,000. Baseline is PowerBuilder client server. Pure PowerServer, the green line, is not going to scale up because business logic is delivered to the client and there are too many round trips to execute interrelated server calls. By moving the business logic to C# Web API, we get back the maximum performance, so the red line. And we serve the data from an open standard architecture on top of the Internet Protocol, cross-platform implementation, and room for scalability, otherwise not possible with PowerServer application. Think about this result and imagine how you can effectively transform your business logic from PowerScript deployed to PowerServer into something which is high efficient cloud-based scenario. Okay, last example before moving to hands-on is data caching, which may help you out to even beat fat client performance. Say you want to implement your own data caching because there are data store holding rows that are not meant to change frequently, and you may hold them into server memory instead of performing database retrieve at each request. So for simplicity here, we declare a session data class that contains a generic data store object and a timestamp for refreshing purpose. The data store cache class declares a dictionary, one among many collection classes that are available in C#, while you do not have these data structures, by the way, in PowerBuilder. So the dictionary is made of a key, a string that identifies the web session for which you want to cache the data store, and the data store itself. And this class has a retrieve method here, which takes the data object name and retrieval arguments, if any. Try get value looks up in the dictionary if there is a data store for the given session ID. If no result, the data store is initialized with typical PowerBuilder syntax: new data store, data object name, and data context, the equivalent of the transaction object. The newly created data store is thereby added to the cache and retrieve is executed here according to the number of arguments that are provided. So no arguments, just retrieve. One argument, retrieve argument 0, and so on and so forth. And finally, the data store is returned to the client, either if cached or just retrieved. And in addition to that, you may want to have a look at the dependency injection features and how to scope your cache service. C# provides 3 methods. Add scoped uses a factory provided by the dependency injection container to inject a dependency that is reused over the entire session. Add transient provides a new instance of the class per each request, and add singleton is for one instance throughout the service lifetime. So if this cache example, in this cache example I just discussed, I've used add scoped. Very good. Now it's time to move to the demo. All right, the first example is the deployment to PowerServer of PowerBuilder as client object functionality. So I'm going to start from the new C# IDE, snap develop, And here I have my web API, the project that follows the usual structure: controller, service, and models. I have a SQL Server data context that is used in the service class to access the database, and the service class manipulates data from the department tables in the AdventureWorks Timo database. For example, let's take the retrieve method, which creates a new instance of C# data store. It sets the data object created by the C# model generator in the PowerBuilder IDE and retrieves it. Then the data store is returned to the controller class. So here is the department controller and the code related to the retrieve method. The controller class answers, in this case, to the HTTP GET request and returns a string. The JSON, which is the JSON export of data store filled by the service. Okay, data store export plain JSON. You can see the HTTP route here. It is server name, then /API /controller name, and /retrieve. All right, then PowerBuilder, and so I have a very simple user interface. This is what I'm going to use in my client application, in my PowerServer client application. So in the PowerBuilder IDE, I have several buttons. Let's have a look at the retrieve. I use the REST object. So the REST client object, also the HTTP client object I can use. So in the retrieve, I call the web API and loads the JSON into the data window of control. So you can preview the results of the web API from the web browser. Paste /retrieve, and this is the JSON data. So at this point, let me deploy and run this PowerBuilder client to PowerServer. So PowerServer is already installed on the local IIS server. A local deployment profile adventure is already configured, and I deploy the app and run it. During the deployment, the code is exported and web files are created and transferred to the web server. So the deployment actually takes 3 steps. At the end, I can run it. You see, in a matter of a second, I will run my PB application into the web browser, and I get the UI from within Internet Explorer. I can select the button and call the web API. So the process of parsing the JSON is automatic. The REST client object matches the data window columns with the JSON keys and fills the data window accordingly. Here I see the columns, and also I have a text box to display the response body, so the actual JSON data, and the response header. So extremely easy. Okay, now the second example is the complex business logic, which has the goal to compare performance between pure PowerServer application and PowerServer in conjunction with Web API. So it is the same Web API project. Let's take another service class, which somewhere down here retrieves another C# data store containing list of some thousand sales order. Then it uses the SQL builder to actually construct the SQL query to select all order details for current order number. Execution of this query is done through the SQL executor, which fills a collection of sales order detail model class. And finally, for each order detail into the orders collection, some mathematics is done, and finally the amount is returned to the controller, which sends it back to the web client. Web client, that is the PowerBuilder application or the PowerBuilder application deployed to PowerServer. It has the following UI. I can specify a certain number of rounds, 5 for instance, and when I click On the Start button, I will run 2 times a 5 rounds simulation comparing business logic with client application that calls the web API versus the client application that connects to the database. And at each round, the number of orders is increased by 2000. And I will run the simulation from here in this function. So I will see that in the first case, when I call the web API, I just specify a GET request to my REST API on the Run SQL endpoint with an argument max order ID. That is to pass on to the service the 2000, 4000, up to maximum 5 times 2000 orders. And when finished, just get the overall price from the HTTP response body. Down here, instead, I have the database code, which is the one discussed in the presentation, with the data store retrieve, and per each order with certain order ID, we declare a cursor on corresponding order detail table, loop over the cursor, and make calculation with the performance killer for a PowerServer application that makes one server call per each row in sales order detail to fetch individual ordered items. All right, time to run the application, PowerBuilder first. The data window to the left shows the 5 rounds, API call first, with round number, number of seconds, number of orders, and total amount of USD for all orders. And the graphic data window to the right shows performance, number of seconds versus the number of total orders. And you can see that, as expected, the higher is the number of orders, the higher is the number of seconds, with the linear proportional relationship as also represented by the pattern in the plot. So let's wait for 5 rounds. Number of seconds is respectively 6, 9, 11, 16, and most likely something around 20 for the 5th round. Okay, and now the code with PowerBuilder client that connects the database starts again 5 times, and the pattern is very similar. So very similar curve, slightly faster because I'm running on local computer, but of course, if you have a dedicated server, you'll probably reduce the gap between the web API call and the direct database call because computing power is better on a server. But the key point is the number of seconds is same order of magnitude, very much the same. Now let's deploy the application to PowerServer and we run the simulation again. So I convert the application into a web app and I will run it from a web browser. There you go. So first of all, we run the simulation with PowerServer calling the web API. Round number 1, 4 seconds. Round number 2, 7 seconds. So if possible, even faster than the PowerBuilder client application. Third round. And then round number 4, so very linear. very scalable, but with number of seconds which are very much comparable with those one obtained in the PowerBuilder client application. So same order of magnitude. And now you see PowerServer application is now starting round number one with the direct database connection. And we're starting over from 2000 order, and the first round is not even finished. Okay, it takes 24 seconds. You will see in the graphic data window to the right the green point at 24 seconds. Now we are waiting for the round number 2 to complete. For 4,000 orders, but as you can already expect, the amount of time will be very, very high. It's not comparable at all with the Web API version or the original PowerBuilder application. So the bottom line is this is the perfect scenario where, even though the case is very extreme, this very complex business logic which performs a lot of round trip to the database is not going to work in PowerServer. All right, thank you very much for your attention. In this presentation, you have learned how to leverage PowerServer for moving your PowerBuilder applications to web and mobile architectures with very little effort, but also how complex business logic may need robust and scalable server-side components, and how the new PowerBuilder C# Web API offers the perfect scenario for supplementing large PowerServer-enabled applications with full-fledged .NET Core and C# REST API. And this will offer you new business opportunity by deploying the possibly IO-intensive functional aspects of your business logic as a Web API, and have PowerServer as a robust framework for converting the UI into a web or iOS, Android mobile application. Thank you very much.